Okay, so here we're going to look at some very common integrals, and I'm going to show you how exactly to find the formulas. I've written a couple of easy formulas here that you should recognize. Width times length is the area of a rectangle, and that's the easiest integral that we're going to find first. So let's say we wanted to find the integral of y equals 3x, or just y equals 3. So 3 is a constant, right? So right here we just have a straight line for y equals 3. Now if I want to find the area, let's say right here, and we want this area right here, how do we find that? Well, it's width times length. Our width is going to be 3, and our length is going to be 3. Now, our length is always 3 because it's a constant, and our width is just the width of the area that we want, the area that we're specifying, in this case x. So our area is just 3 times x. So if you think about it, the integral of any constant c, and here we've done 3, well, that's just going to be the same thing as c times x. And we just proved that using this rectangle right here. So the area of the integral of 3 is going to be 3x. And then if we plug in 3 as our x, we'll get 9. Now we'll look at a slightly harder one, but also a pretty simple integral. So we found the integral of c is cx. What if we want to find the integral now of cx? Well, or the double integral of c. So for now, let's assume for simplicity's sake that c equals 1. So we're just trying to find the integral of y equals 2x, which I've drawn up here. But again, this is a very simple area formula, so we'll try 3 again as our x. So if this is x, and x is 3, so we have x. What is our height? Well, our height is also 3 because y equals x, so now we have x squared. But we also have a triangle, and that means 1/2 of the base times the height. Well, the base is x, the height is x, and we divide by 2. So the integral of just y equals x is x squared over 2. Now, we might start to notice some interesting properties here about these integrals. What is the derivative of x squared divided by 2? This should be pretty easy to do since we just learned this all of last semester. The derivative of x squared over 2 is just x. And the derivative of x is just 1, or c, a constant. So this is further proof that derivatives are really the opposite of integrals, and when we take an integral, we're doing a reverse derivative. So we took the integral twice from c, we got cx, then x squared over 2, and in fact, we can write this as cx squared over 2. Now, every time we take the derivative, we're just going back down 1 in our chain. So we go from cx squared to x, cx squared over 2 to x, and then back down to 1. But when we took the integrals, we went the other way. So this should show you that derivatives and integrals are the opposite, and how we can calculate some integrals exactly, without any Riemann sums or approximations.